we're going to approach this. So this is 16.3a. Here's our objective. I can graph ellipses. Ellipses. And identify the key features. So just like when we started off with parabolas, we wanted to be able to graph them and name the important parts to each one of those. What are the important features on the graph? We're going to do the same thing with ellipses. And then tomorrow we're going to take a look at how we come up with equations for ellipses, given the fact that we're going to understand them pretty well by the end of today. So in the warm-up, these are parabolas, and it says fill in the blanks based on the equation. So on this one right here, the first thing we notice is x is squared. So that means it's either going to open up or down. And we'll notice that this is negative, so this one's definitely going to open down. That's pretty easy to tell. And then the vertex is going to be at h comma k. H is whatever's with the x. It's the opposite of that number, remember, because it does the opposite of what we'd think. So this is going to be at 10 comma, opposite of whatever's in the parentheses of the y, so 10 comma negative 3. Raise your hand if you got those right. Perfect. Wilson, why is there an asterisk by this?
Because there's nothing before the parentheses.
That could be it, but there's another thing that I was kind of pointing out. D.
Is it because it's the y?
Exactly. Whatever comes first doesn't necessarily mean that that's the x coordinate of the vertex. It's whatever's with the x. So what's with the x is a minus 4, so this is going to be a positive 4. What's with the y is a positive 1, so this is going to be a negative 1. Because y squared, it either opens right or left. It opens in a horizontal direction. That's weird. And because it's positive, opens to the right. Raise your hand if you got those two right. Okay, excellent. Okay, so just like all the other conic sections, the equation for an ellipse comes from a definition. So here's the definition, and then we'll look at an animation. We won't worry about deriving it, although I'll point you to something that you can watch if you want to do that. So here's what an ellipse is. An ellipse is the set of points on a plane, the sum of whose distances from two fixed points is constant. So we add up the distance between 2 points and a point on the ellipse, and that's got to be the same all the time. And I'm going to show you an animation that works pretty well here. Would you write foci here? Because the 2 points that we're kind of rotating things around, those are called foci. And I'm going to come over here and we're going to watch this animation. I'll back it up and do it a couple times. This works. This is 8 seconds long, so I'm just going to play this.
That was cool.
Okay, so here's what I want you to notice. As this is going around, notice that on the bottom here, that line goes from blue to red, but it's always the same length. So as we're going around here, and I'm going to stop this, this is the red length indicated down here. This is the blue length indicated down here. And if I move a little bit more, go to right there. This is really short, indicated down here in blue. That one's really long because it's got to go all the way from this focus all the way to the other side over there. But notice that the total distance, the sum of their distances is always the same. You could easily do this. We could take 2 points, 2 thumbtacks, put them on a wall, take a string that's a little bit longer than that distance, and you can just kind of trace out an ellipse. Okay, so if you want to make an oval, that's a way that you could do that. So that's a visual of what's going on. We've got the foci right here. We've got 2 of them instead of just 1 like we had before. Okay, and then we've got this total distance. We've got that constant. Okay, so I'm going to come back over here. If you are interested in seeing how you would derive the equations, you're welcome to type in that link or click on it if you pull it up electronically and watch somebody derive the entire thing. We derived the equation of a parabola. Okay, you can get bogged down. It can get really complicated, but trust that all of those things are going to cancel out. You're going to get the formulas that we're talking about here. So from 16.1, here's what we did. If you watch that video, and I think there's still 2 more people that need to do that. Okay, ellipses have 2 squared variables that have the same sign but different coefficients. Okay, same sign but different coefficients. So the squared variables are both positive or both negative as long as they're on the same side. Okay, but they've got different values in front of those. Okay, and you're going to see that. And if we put it in a graph-friendly form, this is the form that we're going to use. So it's x minus h quantity squared divided by an a squared plus a y minus k quantity squared divided by a b squared. And that's an ellipse with a center at h comma k. Shouldn't be any surprise there. It looks a little bit like the equation of a circle, except for we've got these dividing by an a squared and a b squared. Okay? Notice there are two perfect squares. Oh, I need to write better. Two perfect squares. And the equation has to be set equal to 1. So if we're talking the graph-friendly form for an ellipse, two perfect squares set equal to 1. So we've got some important features that we need to worry about. We've got a center that we're going to find. We've got two foci. We've got two vertices. And then we've got a major and a minor axis. So center, foci, vertices, and a major and a minor axis. So when we're talking about the important features of an ellipse, that's what we're talking about. So I've got a gigantic box right here, and I am going to graph this one. Okay? So I'm going to show you how we graph this, label all the important parts, and then I'm going to show you kind of some of the features that we're going to look at and how we'll do this, on the ones on the assignment. So here's the deal. You'll notice that it's a perfect square with x and a perfect square with y. There's nothing added or subtracted in the parentheses. So what that means is the center is 0, 0. So we'll start off with an easy one. So if it's in this format, in this nice friendly format, we locate the center. Well, we're not adding or subtracting anything, so the center is going to be at 0. So I'm going to put a center right there. The next thing we're going to do is we're going to take the square root underneath the x squared, square root of the number underneath the x squared term. So underneath the x squared is a 16. We're going to take the square root of 16 and we end up with 4. So in the x direction, we're going to go that far from the center and we're going to draw a point. So in the x direction, so horizontally, we're going to go this far, we're going to draw a point. We're going to go this far, we're going to draw a point. Then we're going to do the same thing in the y direction. We're going to take the number underneath the y squared term. We're going to take the square root, so the square root of 7, not a very nice number, okay, approximately 2.6-ish, okay, and we're going to go that far in the y direction. So sometimes we're going to have to deal with some ugly numbers somewhere. In this case, we're going to go up radical 7, so about 2.6, and we're going to put a dot, and we're going to go down radical 7, so we're going to go down about 2.6. Okay. These 4 points, this is a vertex and this is a vertex. This was the center. Okay. You could call these co-vertices. I've heard them called that before. Okay. We're not going to call them vertices. If we do, we'll just say, hey, would you draw the 4 vertices of the ellipse? Technically, those are the only 2 vertices. So what we're going to do is we're going to, as careful as we can, we're going to draw an ellipse that goes around like this. Okay, now, mine usually end up looking like a bumpy potato, and it's not symmetric, but it looks something like that. So we've drawn the ellipse. Okay, the major axis is whichever one is longer. So the major axis in this case is horizontal. It will always go from vertex to vertex. Okay, so there's the major axis right here. The minor axis is the shorter of the two, so the minor one would be vertical in this case. Okay, the vertices are at the end point of the major axis, like we were talking about. Technically, those are the only 2 vertices. The other ones, again, you could call them co-vertices. Okay, now we want to find the foci, because the foci are actually an important feature. Like we saw with parabolas, the focus is called that because if you put a light at the focus and then reflect things off a parabolic mirror, things are going to go in a straight direction. If you have a satellite receiver that's in the shape of a parabola, all of those radio waves coming in from outer space are going to hit the reflector, go back to the receiver that's at the focus. So a focus is an important part of a parabola. It's an important part of an ellipse. So here's how we find this. The formula is this. It's a squared minus b squared equals c squared. It's kind of like the Pythagorean theorem, but it's got a minus in it. I would rather you think of it this way. It's the big one squared minus the little one squared equals c squared. So in this particular case, we're going to do 16 minus 7 equals c squared, because that's a squared, the big one, minus the little one, b squared, equals c squared.
3.
So in this case, 9 is equal to c squared, so c is equal to 3. So you will often find this. We're going to trade some ugly numbers right here. So remember, this would be 0 radical 7, and this would be 0 negative radical 7. Those are ugly numbers, but we trade those for some nice numbers somewhere else. So we go c units along the major axis. 1, 2, 3, put a dot right there. There's a focus. 1, 2, 3, put a dot right there. There's a focus. So notice what we've got here. Negative 4 comma 0, negative 3 comma 0, 0 comma 0, 3 comma 0, and 4 comma 0. All of the measurements on this particular one along that major axis, the 5 really important points that have kind of helped define this, they're all nice numbers. Going in the vertical direction along this minor axis, yeah, we get a radical 7 and a negative radical 7. Not the nicest numbers to deal with, but it is kind of nice that the foci all occur at nice points. What we usually trade is, these are either nice numbers for the focus and ugly numbers for the vertices, or nice numbers for the vertices and ugly numbers for the focus. Okay? All right, any questions there?
Is there a way to have both nice numbers?
Very rarely, but it can happen. Okay? All right, so a couple quick things that I want you to note. The reason we subtract here, there's a good reason. We subtract in this formula so that the foci will be inside the conic section, inside the ellipse. So remember, if from side to side we went 4 units, we've got to be inside there somehow. So we've got to subtract something from that 4 squared. We've got to subtract something from the 16 in order to make that distance from the center to the focus small enough to keep it inside. Everybody good with that? Okay, last thing, and then we're just going to kind of plow through this. You will occasionally see people write 2 different formats. There's the one up there, and there's the one down here. You'll notice that the only change is, they still have an a squared here, they still have a b squared here, there's a 1. You'll notice that the only thing they did is they changed the y minus k quantity squared and put it over the a, and the x minus h quantity squared and put it over the b. The only reason to do that is because a squared has to be the bigger one. So if you remember a squared minus b squared equals c squared for an ellipse, you have to know both of those. But if you just always remember, hey, it's always going to be the big one minus the small one to find out what c is, you only need one format. It doesn't matter whether the big number's underneath the y's or the x's. Okay? Do I need to say that again? If you know this one, and you always do big one squared minus little one squared equals c squared, you only need to know that one formula. Okay? And the reason we're subtracting is so that we have a distance that's inside, so the foci can be inside the ellipse. Yeah.
Doesn't it not really matter, because you can just change, because if you subtract, it's just going to be the same thing but negative.
Mm-hmm. Yeah, if you want to,
really matter,
as long as you understand it, there's lots of ways to work around that. Okay, so I'm going to shrink this down just a tad, and then we'll look at the back side. Okay, and for this, I do want you to think, and I do want somebody to say what they think the answer is. I want you to compare that one with this one. What's going to change? What adjustment would we have to make? Luke?
Basically what you're doing is you're going to rotate the ellipse 90 degrees so that the major axis is going to be vertical.
Perfect. That's what I was looking for. Okay, I was looking for the vocabulary. Luke got it? The only thing that this is going to do is it's going to make the major axis run in the y direction. It's going to make it run vertically rather than horizontally, because the big one's underneath the y, so the major axis is going to be vertical. That's the difference. Everything else would remain the same, so you could take this and rotate it 90 degrees and you'd have the right answer. Any questions? Okay, so we'd go from 4 to negative 4, radical 7 to negative radical 7, and then we'd have our foci right here. It would look exactly the same. It's just we'd switch the x stuff for the y stuff. Everybody good there? Okay, flip the page over. Without looking at the other page, would you write the graph-friendly form for an ellipse? And would you write the formula that helps us figure out C so we know where the foci are?
Oh my. Ready?
Okay, if you know what it is, that's probably enough time. If you don't, you probably need some more time to get it memorized. Okay, raise your hand if you wrote that down. Raise your hand if you think this is the best thing to write down. Put your hands down. There's something I would rather you write than this.
Big minus little equals.
Zach?
Big squared minus little.
Very good. Big squared, so I'm going to write big squared minus little squared, learn how to write, equals c squared. Okay, and that's why it wouldn't make any difference on this one, because you're still going to do 16 minus 7 equals c squared, as long as you know that you're always going to take the big one, regardless of which one it's under. You're going to take that one, subtract the small one. Everybody good there? Okay, so I would rather you remember this one. Okay, so let's come down here, and I'm going to ask Caleb. Caleb, what's wrong with this one right here? What's wrong with that if we're trying to graph it?
Oh, it doesn't have like the a squared and the...
It doesn't. Okay, there's something else wrong. It doesn't have an a squared. It doesn't have a b squared. What else doesn't have, Dane? It's got to look like this,
It's not like over.
which we already covered. Yeah.
It's not set equal to 1.
It's not set equal to 1. That's the big thing. So when you're working with an ellipse, it's got to have two perfect squares, and it's got to be set equal to 1, and we've got to be adding them together. So this is really easy to fix. We're going to take this, and we're going to divide everything by 36. And look how nicely this works out. This is x minus 1 quantity squared over 4, plus this is y plus 3 quantity squared over 9, and that equals 1. And once we're in that graph-friendly form, now we can start figuring out all those key features. So what's the center? The center is, Luke?
I'm just wondering, what would it look like if you tried, if you set it equal to a different number and tried to graph it?
I don't know. It would be kind of like figuring out your own way to write slope-intercept form or something like that. Like you're always, it'd be like maybe point-slope form or something.
All right.
You could try it. You're welcome to. Okay? So the center is at 1 comma negative 3, correct? 1, negative 3. So we're going to go that far. Underneath the x is a 4. So I take the square root of that, and I get a 2. So in the x direction, I'm going to go 2. So I'm going to go 2 in this direction, and I'm going to go 2 in this direction. Underneath the y is a 9, so I'm going to take the square root of that. So in the y direction, I'm going to go 3. So I'm going to go up 3, and I'm going to go down 3. We can tell what it looks like right now. Looks something like this. Ooh, yeah, we got a definite eye on the potato right there. Okay? And we could start going through and we could label things right now. I would like to figure out where the foci are, so it's going to be big one minus little one. So that's going to be 9 minus 4 equals c squared. There's our big squared minus little squared equals c squared, so that's going to be a 5. So that means c equals radical 5. Would you locate where those are going to go?
Oh.
Would you put dots on there? There's no way it's going to be out this way. It's not going to go horizontally because that would put the foci outside the curved part of the conic section. So it's got to be up here, about right there. down here, about right there, and then we're going to see the same pattern every single time. Vertex, focus, center, focus, vertex.
VFCF. Wait.
1, 0. I'm going to write down the center. You'll see why in just a second. 1, negative 3. And then this one is 1, and then negative 6, right? Where's that focus?
1 negative 0.77.
You could do it as a decimal if you wanted. Here's the way I'd like you to do this. Everybody watch. You're going to see why in just a second, and you're going to see some names that will crop up over the next couple of days. I have to start at negative 3, and I went up radical 5, right? So this one is negative 3 plus radical 5. Oops, let me make that show up there a little better.
That's what we're gonna.
That's what you write down.
Mm-hmm. So the point is 1 comma negative 3 plus radical 5. Here's the interesting part. When I write down the one down here, it's at 1 comma, don't say it out loud. We started at negative 3 and we went down radical 5. So this would be negative 3 minus radical 5. Now, don't say anything out loud. Does anybody notice anything kind of interesting about this coordinate? Whoops. About that coordinate. Got it highlighted. There we go. One comma negative 3 plus radical 5 and 1 comma negative 3 minus radical 5. Does anybody notice anything about negative 3 plus radical 5 and negative 3 minus radical 5? They got names. Don't say it out loud unless you raise your hand. Colson, what is it?
Conjugate?
They're conjugates. Yeah, those are conjugates of each other. And you're going to notice a whole bunch of that. In fact, if I wanted to, take a look at this one. I would not do this on a regular basis. This one is 1 comma negative 3 plus 3 because we went up 3. And this one is 1 comma negative 3 minus 3. I'm going the same amount up and down from the center for both the focus and for the vertices. Okay, everybody good there? Okay, any questions? Okay, take a look at that one. Don't say anything.
Oh.
Don't say anything. Luke, what's the center?
2 comma negative 4.
You're right. Dane, if the center is at 2 comma negative 4, can you tell me how far I go in the horizontal direction to get to some vertices or some endpoints on this ellipse? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? Okay, Samar, can you tell me how far I go vertically? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it looks something like this. And Gavin, what's that formula where we figure out how far we go from the center to get to the foci?
The big one squared minus the little one squared.
Big one squared minus the little one squared. Dane, what's interesting about this one when we do big one squared minus little one squared? So whoops, 25 minus 25 equals c squared, so c equals 0, right? So where are the foci and what shape is this?
At the center, and it's a circle.
D?
2 negative 4 because it's a circle.
Yeah, okay. So that would be like taking, if we come back here, that would be like taking the two of these and moving these together, okay, putting them right in the center and then just swinging that around the same amount in each direction. Okay, so it would make a circle. The foci are right on the center. The further the foci get from the center, the more elongated the ellipse is. Okay, so if we move them horizontally, we get a really long horizontally elongated ellipse. If we move them along the vertical, then we get a really elongated ellipse in the vertical direction. Okay, any questions?